Now I just have to see if I can use both my document camera. There we go. Okay, we're going to be doing scale models. You need a ruler and a calculator. Turn on my light. All right, your rulers are numbered. They match your calculator number. All right, so let's measure. This is in the ISN. Okay, everybody got their ISN, I hope. Last 2 pages. Measuring in inches, that would be the side with the lesser number of little marks. Okay, and it says inch. I'm seeing this measurement, but make sure you're getting 0 at the very end of your segment. And then how many marks is this past the 2? Count, if the big mark is where the 2 is, not right above the 2. 1, 2, 3, 4, 5, 6, 7. So this should be 2 7/16 of an inch. Okay, make sure you're measuring because that's not a strength for the students. I know that. Okay, especially the inches stuff. You don't write 0.7. It's 2 7/16. Does everybody see how I'm getting that? Please make sure you know by looking at what's on your paper and measuring it. Everybody should have a ruler. All right, now I'm going to go measure the other one. And I'm going to turn my ruler over because it's awkward for me to be running into my computer. So it doesn't matter if I flip it over and do it this way. I'm just doing 0 at the right-hand side this time. Now that one's a little ambiguous as far as is it between, I see it as only like 1.5 marks back from 1. Do you follow me? It's kind of in between there. So that's the kind that sometimes I have to give some credit for a student giving me maybe 2 different answers. I think it's 1 back from the mark. That's for me 15/16 is what I'm seeing. Okay. So now it says we need to be able to convert these fractions to decimals. So grab calculator. The more you participate, the more you're going to remember later. All right, so I've got mine on, and what you do to convert, and this just says what to type right here. It's telling us to change 2 7/8 to a decimal, type 2 plus 7 divided by 8, and you'll get 2.875. Now we're going to convert the above measures also. So I'm going to take and type 2 plus 7 divided by 16, our first measurement. That's 2.4375. Now you might be saying, well, can't I just round that? And the answer is no, do not do that. All right, don't round it. Because your measurements will be off. Your answers will all be off if you're not just leaving it as what you get. Okay? 15/16 divide 15 by 16, and we get 0.9375. Okay, so those are the measurements in decimal inches. Scale models we're going to be talking about today. Scale models, a scale model or scale drawing is an object or drawing with lengths proportional to the object it represents. So even a picture of yourself is like a scale model of you. It's not the same size as you are, right? Okay. The scale of a model or drawing is the ratio of the length of the model or drawing to the actual length. You're always going to do the model on top over the actual measurement of the actual figure on the bottom. A scale can have 2 different units. 1 inch equals 5 miles. So for example, if you were making a architectural drawing, you might have an inch representing 5 miles if you were doing a map. Okay? Scale is not the same as scale factor. It is not the same. Okay, so don't assume that those are related. They're not. They'll be related in a way that we will convert the scale to a scale factor, though, and I'll show you how to do that today. All right, so now what we're going to do is, I know most of us, we find out how far places are away by hitting Google, right? Google our maps. We do that now, and we have that luxury. Back in the day, we didn't have that. There are still maps out there, actual maps. What if your phone died and you were out in the desert and you had a map? You could use this type of stuff to be able to figure out some things, like how far away you were from the next place to get some water. All right, so there are still reasons to know how to read a map and do these kind of conversions. Can't always use technology. All right, so this map and a ruler to find the actual distance between each pair of cities. First of all, what's the scale on the map? You should have met a map before. You go over here and you say they see that little box on there, and that's your scale. Okay, and what this is saying is that the scale is 1 inch is equivalent to 1.88 miles. All right, so we're going to measure to the nearest 16th of an inch the distance from Highland Park and Metuchen. So I find Metuchen on my map, and I'm going to get to Highland Park. So I'm going to put 0 myself. Oops, I'm on the wrong side of my ruler. This side is the centimeters and millimeters. So if you're on the wrong side, flip it around. I was. All right, so you can make a line from Metuchen if you want to Highland Park. You don't have to. But I'm seeing it as 1, and then, I don't really want to count all those marks. So here's a way to count it quicker. If I'm almost to the 2, if I go back 2 from there, that's where I'm landing. And that would be 16 minus 2, which is 14. So I'm going to say 1 and 14/16 is my measurement. Okay, that's 1 and 14/16, which I could reduce the 14/16 to 7/8. But I'm going to convert it to a decimal anyway, so I'm just going to go ahead and type that on my calculator. 1 plus 14 divided by 16. That gives me 1.875 inches. I want to find out how many miles that actually is. So I'm going to need to set up a proportion. I know that the scale, so I'm going to say that equals my scale, which is 1 inch is worth 1.88 miles. Now, I'm showing you to do it as a proportion because not all scales will be in a 1 to something ratio. This one is, so it's actually easy to just multiply our measurements by 1.88, but I'll show you that in the proportion. I got inches on top of my scale. So I'll be finding X miles on the bottom. If we multiply across, that would be X doing our cross product property. We would have 1 times X is equal to 1.875 times 1.88. So that's what we need to calculate is 1.875 times 1.88. I got 3.25. Okay, you're going to get a bunch of weird decimals, so let's just go with it. All right, I'm going to write the whole thing down. 3.525. I hope I said that right. I did? Okay. 3.525 miles. Now that's pretty exact, but good enough. All right, now we're going to do Brunswick and Robinville and find out how far apart they are. So Brunswick is down here. And I got to go to Robinville, which is way up there. So I think it's going to be further. So it's good to think in your head whether the answer will be bigger than the last one or smaller. I think it's going to should be bigger. I don't know. What's that measurement? My ruler's got some really crummy marks right here. It's been rubbed off. I'm getting 2, 8, 9, 10, 11. 2 and 11/16. How about you guys? 2 and 11/16. All right, I'll go with that since you agreed with me. 2 plus 11 divided by 16 gives me a nice decimal. I'll write down it was 2 and 11/16. And then I'll expect on your quiz or test to see the decimal equivalents underneath 2.6875. All right, that was my inches we're measuring. X miles. I know the conversion factor is 1 inch is worth 1.88, or the scale is 1 inch is 1.88 miles. Cross multiply. So 2.6875 times 1.88 will give us our what we're looking for. 5.0525. Now, I'm just going with writing exactly what we're getting down to on the calculator because I don't want you to start rounding your inches, right? Everybody okay? All right, anybody need this though? All right, let's go to the next page. This page, I actually don't need to use this machine. I'll come back to it as needed. Okay, and I'll just I thought it would be quick, but all right, you already know that this is continued, and somehow we have the wrong label up here. What section is this? It's actually 7.7, not 7.5. I don't know why that says 7.5 continued. All right, using scale factors. The scale factor of a drawing or scale model is the scale written as a unitless ratio in common units. Scale factors are always written so that the model length in the ratio comes first. Okay, so we're going to do model on top over actual on the bottom. Okay, if you're going to do a scale factor, you must have common units, then reduce. So the scale that we were given on that map was not in common units. Now I really don't want to change 1.88 miles into inches. That would actually be the scale, which would be incredibly large. So let's talk about something with a little smaller scale. A dollhouse that is 15 inches tall is a scale model of a real house with an actual height of 20 feet. What is the scale of the model? Well, the scale is simply 15 inches to 20 feet, which should be reduced. Reduced would equal, divide by 5 top and bottom would be 3 inches is worth 4 feet. That's your scale. That is not a scale factor. Okay. Next, we're going to take and do part B, which would be to find the actual scale factor. Sorry, I wish I'd had a blank one of these. I don't want you. Let's go for it. We got how many times as tall as the actual house is the model. Now, that's going to be a small amount because the model is going to be on top. We're going to do a unitless ratio. So what we just found out was 3 inches to 4 feet was the scale. All right, we have to convert the scale to a scale factor. What do you think we should change? We have to get a common unit. Come on, guys, thinking caps, please. What should you change? Inches or feet? I don't know. Do you want to write 3 inches into feet? Or do you want to write 4 feet into inches? I hope you know you want to change the feet to inches. All right, we better know that, and we should know already how many inches are in a foot. 1 foot is worth how many inches? I didn't hear enough people say 12. I wish I'd heard a lot more. I hope you know it. You might know it, you're just quiet because it's late. All right, so we need to convert 4 feet would equal 4 times 12 inches, which is 48 inches. All right, so here's how we have to do the scale factor. The scale factor is going to be 3 inches compared to 48 inches. Now, because we have the same units, that's how it becomes a unitless ratio. The inches can be canceled out, And then we need to reduce 3 over 48. If you are not comfortable with doing that in your head, you may use your calculator and just hit the buttons and say 3 divided by 48. And you could have used the 9. I'll go back and show you that it wouldn't matter what one we used. Hit your math, enter button. And that'd be 1 to 16. All right, so the scale factor SF is 1/16. That means the model is 1/16 of the actual house. Or in reverse, it means that the house is 16 times larger than the model. Okay? This would have worked had we used the other numbers. Let's say you hadn't reduced your scale and you did 15 inches over 20 feet. If you had done that, you don't have to write this, but you would have had 15 inches. 20 times 12 would have been 240 inches, and that still reduces to 1/16. All right, so it wouldn't have mattered which one we used. All right. Next. Oops. All right, I'll let you copy that since I've already got it here. All right, scale. The units, oops. Forgot I had the eraser. The units can be different in scale, like 1 centimeter is 3.5 miles. That's an example. Units can be different. So we're just explaining the difference between scale and scale factor. When you're doing a scale factor, it has to have common units, and it tells how many times as big something is. Example, 1 to 75 would mean, you can be written with a colon, would mean the model is 1/75 of the actual item. Okay, I know I need to wait a second here still. Okay. And then we'll be going on to the packet. So I'll get ready while you're copying. All right. Think we can go on now? Okay. Let's, I'm going to have to jump over now because I don't want to have to use this ruler that won't match your measurements. So I'm switching to the document camera. Expand the size of that. I'm going to measure how big is that first segment. Get your inches side, make sure you're on the correct side of your ruler. Don't round that to 1.5. It is 1.1 and 4. Oh wait, was that 7? 1 7/16. 7 marks past the 1. Is anybody confused where the 1 is? It's that longer mark here. That is where the 1 is. So I counted 1, 2, 3, 4, 5, 6, 7 marks past the 1. Are we seeing it? Make sure you have 0 at the left end. All right, so I got 1 7/16. The second one. Oh. It's kind of in between, isn't it, a little? I'd have to give some leeway on that measurement. 1 and, let's see, 8, 9, 10, 11, 12. 1 and 12/16 or 13? What do you think? Some of you did 12, some of you did 13. I think it's closer to 13. So I'm going to do 1 and 13/16. I know that's about half of you did that, half of you did 12s. You do your own conversion, and of course on a quiz I'm not going to get super nitpicky if it's in between. This one's 2 though, right? All right. Now down at the bottom it's just asking us to practice again converting. So if you were zoning out a little while ago, you better get with it now so that you will remember how to convert a mixed number into a decimal. 1 5/16, you type 1. Okay, 1 plus 5 divided by 16. 1.3125. Do not drop or round. The next one, 1 plus 7 divided by 16. We're converting the measurements we did. 1.4375. And 1 plus 13 divided by 16. 1.8125. Now, if you did 12/16, you had 1.75, right? If anybody did 12/16, 1 plus 12 divided by 16. I think I'm forgetting something. No, yeah, I was right. 1.75. Okay, we read this already. A scale model or scale drawing is an object or drawing with lengths proportional to the object it represents. The scale of a model or drawing is the ratio of the length of the model or drawing to the actual length. So we always do model over actual. And a scale can have different units. The scale on this particular map, now this is why we must set up a proportion to do the problem. This one is a little more awkward than the previous one, which had 1 inch is 1.88 miles. The distance from Pineham to Menlo Fields, let's go. We've got a scale of 0.75 inches is 6 miles. So our proportions will be, with that scale, equal to our measurement over X miles. So Pineham to Menlo Fields, I got to measure. I got 1 and 1/16. We good? All right, 1 and 1/16. Let's convert to, pardon me? Oh, 1.0625 is the decimal. In our proportion, we'll put that 1.0625 inches on the top, and we will be getting the X, or actual miles, in a minute. We do cross products, property, giving us 0.75x equals 6 times 1.0625. What we need to calculate, and I'm sure you've probably gotten familiar with it, is x is going to be 6 times 1.0625, and then we're going to be dividing by 0.75. So we can type that all at once. 6 times 1.0625 divided by 0.75. I got 8.5. Did you guys get 8.5 already? I hope you tried it. So I got 8.5 for x, which means that the distance between Pineham and Menlo Fields is 8.5 miles. All right, we're going to try Devon and Pineham. Denville and Pineham. It's a small measurement. How many 16ths are you getting? I got 7/16. I'm putting 0 in the middle of the dot. 7/16 of an inch. Okay. 7/16 as a decimal. 0.4375. That's inches. We're going to find out how many miles that equals. With our scale is 0.75 inches is worth 6 miles. Okay, so we want to do cross products and divide. So I know most of you just probably go right onto your calculator and do cross multiply and divide. I don't know why this isn't showing. 6 times 0.4375 divided by 0.75. And I typed something goofy. Did you guys get 3.5? I just actually had a negative sign in there. Is it 3.5 miles? Okay. All right. We have a few more measurements to do. All right, here we go. Same scale, guys. 0.75 inches is to 6 miles. So all of these are going to be set up the same way. Oops, that's inches. Miles, and then we're going to put our measurement on top and X on the bottom.
Pardon the interruption.
Yes?
We sent Emily Adams to food services. She's leaving.
Okay.
Thank you.
Thank you. All right, Eastwick to Needham Beach. Eastwich or Wick, whatever it is. How far is that? Oh, I think it's 1.5, isn't it? Is it right on there? 1 8/16. Okay. I need to see some rulers moving. You guys need to practice measuring. Please don't just be sitting there waiting for someone else to measure it for you. 1 8/16, that should be coming out as a decimal of 1.5. All right, so we'll be putting 1.5 inches in our numerator. Just go ahead and do 6 times 1.5 divided by 0.75. All right, I'm not calculating these. I'm going to start asking you guys what you're getting. How many miles is it actually? Boy, did you get it? You got 12 miles? Did you calculate it? Okay. Other people got 12 miles? Anybody not get 12 miles? All right. North Park to Menlo. All right, let's go North Park to Menlo from way up here. Please do not say that's 2. It's not. What do you say? 2 and 1/16. All right, 1/16. Convert it by typing 2 plus 1 divided by 16. 2.0625 goes into your formula. Find the distance, please. What's the actual distance from North Park to Menlo? I should see people calculating right now. Okay, how many miles is that? Lexi? Yep, that's right. 16.5 miles. Anybody not get that? You need help? Do you see that not rounding this? If you went and just said it was 2 instead of a 16, you'd be off half a mile. Do you think that'd get you where you're going? Half a mile is kind of far off. No, not the best thing to be half a mile off. All right, North Park and Eastwick. Okay. What measurement are you getting on that? Abby? How many 16ths are you getting? That would be fine. Yep. Everybody getting 14/16? That's correct. Okay, and then convert that. 0.875. And do your thing. Find out that distance, please. How many miles, Lauren? 7. Yes. Any problems with that? No. Okay. Next, we got to do some word problems. I'm going to get off this document camera and go back to our Easier to read screen. All right, we're on the question on engineering. Oh, actually, but prior to that was using scale factors. The scale factor of a drawing or scale model is a scale written as a unitless ratio in common units. You have to reduce. Okay, and the model is going to come first. Here we go. Engineering. A civil engineer is making a scale model of a highway on an on-ramp. The length of the model is 4 inches long and the actual length of the ramp is 500 feet. Imagine how much they have to do with roads. Oh my goodness. A lot of roads out there. What's the scale of the model? The scale, that's when you can have different units. So 4 inches to 500 feet. That is your scale, except we should reduce it. And that would be 1 inch to, you can type that on your calculator, hit your math enter. You should be getting 1 inch is comparable to the 125 feet. Okay, now, how many times as long as the actual on-ramp is the model? Okay, so we're going to see how small the model is compared to the ramp. So we're going to do model on top. So we're going to take that same, say you just use these numbers, which you started with there. You got to convert. So I can't have 500 feet. I have to change that to common units. Change to common units. All right, now, what does that mean? Convert from feet to inches or from inches to feet. One or the other has to be converted. I don't think I want to do 4 inches and make it into feet, right? It'd be a fraction. So let's do the conversion of the 500 feet. So we'll take 500 times 12 inches to get it in both inches, top and bottom. So 4 inches, what's that, 6,000? Okay, and then we do, that's in inches now. The whole point of scale factor is to get rid of the units because the inches are both on top and bottom, and let's get it reduced. So we need to reduce to get the scale factor. Scale factor is 1 over 1,500. Now, what does that mean? Okay, that means the model is what? How would you say it? Is 1/1500th of the actual ramp. Okay, the model is 1/1500th of the ramp. Now, if you reverse that, that would mean that the ramp is 1,500 times bigger than the model. Yes, you can say that, but if you were going to give it as a number, it's 1/1500. So actually, that sounds kind of weird if you thought about decimals, but you couldn't really do that as a decimal since it's not in tenth. Right, I don't know, just sounded weird. Tokyo Tower in Japan is currently the world's tallest self-supporting steel tower. I actually don't know that it still is, but I wouldn't think it probably is. This book was written a while ago. It's 333 meters tall, and I found out a lot of my students don't really know a lot about converting from millimeters to meters. Hero builds a model that's 2,775 millimeters tall. What's the scale factor? So since I want a scale factor, I have to do the model on top, and I have to compare that to the 333 meters, but those aren't the same labels. So I have to convert. How many millimeters are in a meter? Does anybody know? Okay, let me ask this. Does anybody know how many meters are in a kilometer? No one? Well, at least you got the power of 10 correct. Actually, not the right power of 10, but you got the fact that it's in powers of 10. Did you know that they increase by... We used to have a class called Math Connections, and we retaught this meters, liters, grams stuff. And millimeters is down here, and kilometers would be your biggest one. Oh, yeah, I can tell that we remembered that, huh? It didn't come out because I don't hear anybody giving me the answer. So, do you know its powers of 10? So, if this is 1 meter, how many millimeters are in it? 10 times 10 times 10. 1,000, okay? There are 1,000 millimeters in 1 meter. And in the kilometer, 10 times 10 times 10, there are 1,000 meters. I'm breaking it down real simply. There are other labels between here. There's centimeters. There are here the decimeters. And then there was the hectometers. That was 100. Okay, anyway, I'll stop there. But the point being, their power's a 10. All right, so we just found out there are 1,000 millimeters in a meter. So we got to multiply this by 1,000. Okay, so here's what we got to compare and reduce. So we're going to have 3, 3, 3, and we're going to have 3 zeros on it. So that's 333,000. We're going to divide, do it on our calculator. 2, 7, oops, my 7, something's stuck here. I'll try to get it to work. There we go. Oh, I have too many 2s. You guys are probably already done, and I'm still trying to push the buttons. All right, so we got 333,000 on the bottom, and then go to your math center, enter 1 and 120. All right, so the scale is 1 to 120, which means that the model is 1/120th of the actual tower. Okay, a few more. Architect prepared a 12-inch model of a skyscraper to look like a real 1,100-foot building. What's the scale factor? So I got 12 inches. Oh, I'm going to think of a simple way to do this one. What do we know about 12 inches? Yes, let's do 1 foot over 1,100 feet. Cancel out the feet. And we got 1 to 1,100. That was nice and convenient that they gave us 12 inches. All right. 7, you got the Eiffel Tower in Paris, France, 986 feet tall, not including its antenna. A replica of it was built as a ride in an amusement park. If the scale factor of the actual tower to the replica is 3 to 1, 3 over 1, this was actual, this is the replica, then we want to know how tall is the ride. The replica is the ride, so that'd be X on the bottom. The actual tower was 986 feet tall. So this is lending to a proportion for us to solve. So cross products, 3 times X equals 1 times 986. Divide by 3. How tall was that ride? Was or is, I don't know if it's still there. Someone, 300 and what? 0.6 repeating, which is 2/3 of a foot. I could change that to inches, but 328.6 feet tall. That is a tall ride. That is over 30 stories tall. This ride, sorry. I don't know what else it would be, but it was ride. So I just wrote kind of fast and my two things blended together. All right, number 8. Oh, do you know they make models to do your movies with your thing like Godzilla in it? Okay. Because obviously there cannot be a person that big. Did you know that that's physically impossible for there to be giants? Mm-hmm. They would not be able to withstand the gravity and have the same dimensions as an actual person. It's impossible. That's why large animals have large feet, like elephants. Their weight to be supported needs to have a very large diameter of a bone. Anyway, that's enough about that. So Paul Bunyan couldn't exist. All right, a boxcar train has a length of 40 feet wide and 9 feet. All right, scale model is made with a length of 16 inches. Find the width of the model. All right, 40 feet. That's the length. Okay, you've got a 9 feet for the width. All right, I got to set up a proportion. Okay, so what am I going to do with my stuff I got for my model? Sit still. Length is 16 inches. Find the width of the model. It says find the width. So where do I put an X? Under my 9 or my 40? All right, now under the 40. All right, the length is 16. Okay, now, you don't have to worry about units. You just do cross products. We got a proportion. So 40X equals 144. 16 times 9 is 144. Divide by 40. And what was it? 3.6. It's not repeating, is it? 3.6 inches on the model. All right, notice that we just finished in the nick of time. Please practice. Tomorrow I'm going to be taking questions on 7.5 homework and 7.7 homework.